Good day, everybody. It's a new week. You are welcome to TPATHS Learning Center. As supposed to last week, we had a class on energy and chemical reaction. I had feedback from the fact that some were feeling like the topic were kind of difficult. So I'm here today to just shed more light on that. So I'll be treating some questions on that concept. I'm treating some questions on energy and chemical reaction. We need to understand what questions can come out from that section. Because if you are doing chemistry in JAMB, that is a good area of exam questions. So the first question you have there is we're told that when sodium chloride and metallic sodium are each dissolved in water, what happens? That is, you are dissolving a metallic substance or sodium chloride in water. What we observe is that both processes are exothermic. B, both processes are endothermic. C, the dissolution of metallic sodium is exothermic. And D, the dissolution of sodium chloride is explosive. Now, the funny thing about this question is that when we dissolve sodium chloride in water, what happens is that sodium chloride will break into Na plus and Cl minus, and that is called dissolution. That is called dissolution. And in the solution of sodium chloride, you need to know that the sodium sodium chloride is, what I said in the last part of the solution, is endothermic. So you want to break that reaction, then you need to gain energy to break that reaction. So both processes are endothermic. So we can go with the fact that both processes are endothermic. And what are endothermic reactions? Endothermic reactions or processes are in which there is what? There's gain of heat. Sorry, in which the heat is being absorbed from the surrounding. Then put in that form as 2. Number 2, when it is absorbed in a chemical reaction, the reaction is said to be what? Endothermic. You can easily see simple question like this. So when heat is absorbed from the surrounding, it's called an endothermic. When it is lost to the surrounding, it's called an exothermic reaction. 3, the reaction 3C plus 2Fe 2O3. This is that reaction, so you can understand something there. 3C plus 2Fe 2O3 give us 4Fe plus 3CO2. Delta H is equal to minus 46 kilojoules. Now you can see clearly here that the enthalpy is a negative. And we need to recall that negative enthalpy means exothermic reaction. Exothermic reaction. It means exothermic reaction. Please let's note this. Negative is exothermic reaction. Positive, if you have a positive at delta H, is called endothermic reaction. Endothermic reaction. Endothermic reaction. Endothermic reaction. I hope you are all following. Next question. An endothermic reaction is one during which heat is dash and can be represented by the symbol dash. Which of the following combination can be used accurately to complete the above definition? Endothermic reaction is one during which heat is what? Heat is absorbed. Heat is absorbed. Heat is absorbed. And we are asked again, and can be represented by the symbol what? Positive delta H. Positive delta H. We can even pick the answer there. To absorb positive delta H, that's option D. Option D. To understand your question very, very well. Understand it is a good area of question. D. When sodium nitrite dissolves in water, H is positive. This means that A, the reaction is catalyzed. B, the reaction is complete. C, the reaction is endothermic. D, the reaction is endothermic. Sodium nitrite is directly soluble in water. Now, when sodium nitrite dissolves in water, H is positive. It means that sodium nitrate has broken down into its various ions. Has broken down into its various ions. And we can say the reaction is what? The reaction is exothermic. Exothermic. It's exothermic. 0.16 gram of methane. Now you can also how will I put it? You can also have a reaction whereby you are comparing enthalpies. You are comparing enthalpies. So in this case here, we are told here that 0.16 gram of methane, 0.16 gram of methane, when burned raises the temperature of 100 gram of water by 40 degrees Celsius. What is the heat of combustion of methane? The heat of water is 4.2. Let's write the data. 0.16 gram of methane. Mass of methane is 0.16 gram. When burnt, raises the temperature of 100 degrees Celsius water. It should be degrees Celsius. Temperature T1 is 100 degrees Celsius. Sorry, it's the mass of water. Mass of water is 100 grams. Based on water by what? T of water there is 40 degrees Celsius. What is the heat of combustion? Heat Q is unknown. Of combustion of methane, when the heat was of water, C of water is what? 4.2 joules per what? Per gram per degree Celsius. So now we are told here, first of all, we need to know one thing, that Q is equals to MC change in theta. Equal to MC change in theta. What is the mass here? The mass, what the mass, so the mass I'm talking about here is, we need to know, is it the mass of water? Is it the mass of the gas? So the mass I'm talking about here is the mass of the gas. That is 0.16 times, what is C? C is 4.2 joules per gram per kilogram. So we need to do one thing. We need to convert 0.16 to kilogram. Isn't that better? Because mass is in gram, C is in joules. Okay, it's okay. We don't need to convert because C. We don't need to convert the mass to kilogram. Why? Because C is in joules per gram per degree Celsius. So times 4.2, then delta T. The change is, but the temperature is 40 degrees Celsius. So we need to convert this to Kelvin. So 40 plus 273, that is 313 Kelvin. To 313. Or, as I said, the question is given us, it said degrees Celsius minus 1. So we don't need to use this. Why? Because look at the question. The question will guide you. The question will guide you. You can see that the H, the solution of water is what? So 4.2 joules per gram per degree Celsius. So we don't need to convert. We will work with 40. We work with 40. So let's do this math. Then put 2 points my calculator. 0.16 times 4.2 times 40. So something is fishy here. Something is fishy here. I feel that the temperature of 100, is it 100 gram or I don't know. Something is fishy in this question. Something is not complete in this question. Hopefully you see something like this in the next question so we can explain this concept very, very well. The question, something is missing in this question here. That's why I cannot get the answer properly. That should be it. The next question, they are told that the energy change of the reaction CO gas plus CO plus alpha to CO2 is, we don't know it, but we're giving the question, we're giving that HCO is equals to minus 110.4 kilojoules per mole, and HCO2 is equals to minus 39 kilojoules per mole. They will recall that we need to give a balanced chemical equation, that is CO plus half O2 will give us CO2. Therefore, delta H will be equals to H product minus H reactant. And what do you have here as the product? CO2. So HCO2 minus open bracket. This is the reactant HCO plus half HO plus half HO2. So knowing that, we can continue. So HCO2 of the equation HCO2 is minus 393 minus HCO is minus 110.4 plus half H of O2 is 0. Why is H2 0? Please note one thing today. O2 is the standard form of oxygen. It is the standard form of oxygen, and it will assume a standard value of 0. For all standard forms, they assume a standard value of what? Of 0. So for oxygen gas, we have O2 as the baseline for oxygen. For carbon, we have carbon graphite. For sulfur, we have monoclinic sulfur. So in cases like this, the enthalpy will always be equals to 0. So let's note that. That's why in the question you are not giving the value of the enthalpy. So you can work with that. So that means we can evaluate this to get minus 393 plus 110.4. Minus and minus to give us plus. So doing this expression here, we should get. So you can easily punch your calculator for this. That is minus 393 plus 110.4. So this is minus 282.6 kilojoules per mole. Please note your unit. Note your unit. So in this case, we observe the question. We are given the enthalpy of CO. We are given the enthalpy of CO2, but the enthalpy of O2 was not given. So you need to note that the enthalpy of a standard value is always 0. So O2 is the standard value, carbon graphite is the standard value, monoclinic sulfur is the standard value too. So it is going to assume a value of 0. So knowing that HCO2 minus HCO plus half HO2, and I imputed the values to get minus 282.6 kilojoules per mole. Let's see if we have the answer there. There's no, okay, we have an option there. We have minus 282.9. But we believe that is closer to the answer. Maybe it's typo. So that makes more sense. The next question, they said, tetrahydrosulfate 6 acid is prepared using the chemical reaction SO2 plus H2O, giving us H2SO4. So you are hydrating water with SO2. Given the heat of formation for SO2, H2O, H2SO4 as this. Another question again. Let's do this so we can understand our concept very, very well now. Let's do it together. So please follow me. Let's do it together. So in this question, we are given the heat of formation of the various substances that form H2SO4. So let's see what happens here. So we have SO2 as minus 395 kilojoules per mole. The enthalpy of it, enthalpy of H2O, we are given enthalpy of H2O is minus 286 kilojoules per mole. Enthalpy of H2SO4, we are given to us as minus 811 kilojoules per mole. Minus 811 kilojoules per mole. Minus 811 kilojoules per mole. Now, knowing this, I believe we can solve. So we can, first of all, we have to write the balance. Please note the balance chemical reaction. So SO2 gas plus H2O gas will give us H2SO4. H2SO4. H2. So it's SO3 that is here. The question here. SO3. H2SO4. So we can solve. So delta H formation, delta H reaction rather will be equals to H of product minus H of reactant. And the product here is what? H2SO4. That is what? The product here is H2SO4. And the reactant is H2O and SO3 respectively. And SO3 respectively. And SO3 respectively. So you see the type of questions, they come out. You need to practice very, very well. So product, that is what? H of H2SO4 minus open bracket H of H2O plus H of SO minus H1 minus open bracket. What is H of H2O? Minus 286. H of SO3 is minus 393.5. So let's be calm with this. So we know that, let's just do it in the bracket first. We don't confuse ourselves. Let's do that in the bracket first. Calculator. So 286. 286. 286. One first identify first the one that is in the bracket. So this is minus 811 plus everything here is giving us 679.5. 679.5 minus 811. This is equal to minus 131.5 kilojoules per mole. So this is the answer. Minus 131.5 kilojoules per mole. So we're having minus 130 there. You can assume that is the answer. So the next question, number 15. The diagram above shows the reaction part of an exothermic reaction. The heat of reaction is represented by her. What is the heat of the reaction? You can see the reactant, you can see product side, you can see the activation complex, we can see. So the heat of reaction is IV. The heat of reaction is IV. Let's know that. The combustion of 18 situation is given by the equation C2. If the molar heat of formation of water and add this, calculate it formation. So number 18 is an assignment for you guys. So you'll be given the slide, practice it, and look at the questions there. If it tallies with what you are getting. So number 18 is your first question as an assignment. 19, Fe2O3. So the same thing again, number 19 to 20. Let's do number 20 together. So 18, 19, please, ladies and gentlemen, note it. Because you're going to do them. Now use that to practice and check if you are correct. So let's go to number 20. Number 20. So you're told here number 20 that 1.1 gram of CaCl2 dissolved in 50 cl of water causes a rise. So 1.1 gram of CaCl2 mass is 1.1 gram CaCl2 calcium chloride dissolved in 50 ml of water. Volume of water is 50 cm cube. Cause a rise in temperature. So delta theta is what? 3.4 degrees Celsius. The heat of reaction H for CaCl2 in kilojoules per mole is, we give that C is equals to 4.18 kilojoules. So now we need to do this. So let's do this. So we can record that Q is equal to MC change in theta. Your mass is 1.1, C is 4.18 kilojoules. That is converted that to 4180 joules. Delta theta is what? Your delta theta? The delta theta is 3.4. 3.4. So this, evaluate that first. This is what you can get. 4180 times 1.1 times 3.4. I'm having 15,663. Wait. Okay. 15633.2 joules. So now, 1 mole 1 mole of CaCl2. Then we're now having 1 point, that will be CaCl2 is what? 40 plus 71. That is 111. So 1.1 over 111 mole. I want to get the number of moles. So 1.1 times 156. Getting a various answer that is not in the option. Per joule. It is, let me cross check my solvents. Okay. Please hashtag this. I'll come back to this next class. Please hashtag it. Please hashtag this. I'll check the question here. The chemical reaction in which the hydration energy is greater than the lattice energy is referred to as dash. And the thermic reaction, the reversible reaction, is spontaneous reaction. So for the hydration energy, normally lattice energy is an exothermic reaction. Lattice energy is an exothermic reaction. So you'll now be in a state whereby a hydration energy is greater than the lattice energy. What happens? Lattice energy is the energy that involves in the what? Breakage of a crystal lattice of a substance. So hydration now you are just trying to, the substance is being dissolved in water. It's going to, so the answer is what? It's an exothermic reaction. It's an exothermic reaction. So the thing there is that when you dissolve a crystalline substance in water, if the hydration energy is higher than lattice energy, you observe that there will be what? An exothermic what? Reaction. CO, okay, we can try 62 on our own. 18. So what so far? Your assignment so far? 18, 19, 62. If the change in period of the system is now now we need to know something, which is what I didn't bring. Which is what I didn't use in the last class. I didn't talk about in the last class rather. Is second law of thermodynamics. Second thermodynamics state that a spontaneous reaction will lead to a what? To a higher entropy. So, and from there to what? A spontaneous reaction. We learn our spontaneous reaction. In a spontaneous reaction, is a reaction that takes place without being forced. You don't force it. It just happens. That's what it's called. That's what a spontaneous reaction is called. So we can have what they call positive entropy and negative entropy. So higher spontaneous positive spontaneous process. A spontaneous process is positive, that is spontaneous process. Spontaneous process. While a non-spontaneous process is negative, that is non-spontaneous process is a negative S. So that you need to know about this. So delta G equals delta H minus T delta S. So we are told here that if the change in the free energy of the system is that delta G is equals to minus 899 joules per mole. And the enthalpy change is 10 joules. Delta S is 10 joules per mole. Per Kelvin. So calculate the enthalpy change. Delta H is unknown. Now you can see here that in the question they're giving the temperature. So don't joke with that. If they give you the temperature, you read the question and understand. The question the temperature given to you there is 25 degrees Celsius. 25 degrees Celsius. So T is what? 25 degrees Celsius. Convert to Kelvin. This will turn to what? 25 plus 273 is 296 Kelvin. So when you add from Celsius to Kelvin, you add everything. So therefore, I can solve from here. From here, I can say H is equals to delta G. Delta G is minus 899 plus what is your T? 298. What is your delta is times 10. So if you evaluate this, so this gives us minus 9 plus 2980. 2980 minus 2081 joules per mole. So this is the enthalpy of the reaction. So minus 208. That is option A. The forward reaction is favored by chemical equilibrium here. You can apply it. So you can say the delta H is positive. This is positive. You want to favor the amount of protein, you have to increase temperature. Because for an endothermic reaction, if you increase temperature, then what will happen? The reaction will move what? Forward, and there will be more of the product formed. So that's a very direct question. The answer is D. A chemical reaction with entropy change. Okay. I don't want you to practice 70. From the above, we can reduce that. We learned that for an exothermic reaction, the heat of the product for exothermic, the next one, 34, exothermic reaction, we learned that delta H of product is greater than delta H of what? Delta H of reactant. Why for endothermic reactions, delta H of reactant is greater than delta H what? Of product. So from that question, that was on the test of that question. They said in the reaction above, from the equation above, rather, it can be deduced that the heat content of the reactant is lower than that of the product. The heat content of the reactant is lower than that of the product. That is correct. Because why? It is an exothermic reaction. That is correct. Next, the degree, the entropy and enthalpy of the system, and a measure of what? What is entropy? Entropy is a measure of the degree of disorderliness of a system. How disorderly the system is called entropy. For example, now you have a solid, you have a liquid, you have a gas. We can say the gas has higher entropy than liquid and solid. Why? Because gas has what they call weak intermolecular forces. Thus, the molecules can move freely, but solid has the lowest entropy. Because in a fixed position. For that there that the enthalpy of a system to enter its content of the system. In the perspective. So guys, you have seen what you've done. The bridge between this and chemical, all these things you've done. And I'll let with 1, 2, 3, 4. For you that I believe that will be all for energy and chemical reaction. So next class we start a new topic. Thanks for your time, guys. We really appreciate it.